All right, ladies and gentlemen, today we are starting factoring, okay? And before we actually start factoring, it would be important for us to know what factoring is, okay? When you write a number in terms of its factors, what you're really doing is you're just changing that number into multiplication of prime numbers. So for example, you could rewrite 6 as 2 times 3. That would be factoring the number 6. Or you could rewrite 8 as 2 times 2 times 2. That would be factoring the number 8. When you're doing it with polynomials, what you're really doing is you're trying to write it into taking like a big quadratic trinomial, which is what all these are, something that starts with x squared and has 3 terms. What you're trying to do is write it in terms of smaller polynomials, like binomials that are multiplied together, okay? Basically, in short, what you're doing is you're undoing the multiplication process. So with that in mind, the first thing we need to do is recap multiplying polynomials and make sure we remember how to do that, because factoring is entirely based off of undoing that process. So taking a look at the first one, reminder of what we do, we're basically doing the distributive property over and over again. So we're distributing our x to the second binomial, and we get x squared plus 4x. And then we're distributing our 2 to the second polynomial, and we get plus 2x plus 8. And then we're combining our like terms, and you should get x squared plus 6x plus 8. Again, what the process of factoring is going to be is instead of starting with x plus 2 and x plus 4, you're going to be starting with the x squared plus 6x plus 8 and trying to work your way back to x plus 2 and x plus 4. But before we do that, let's see if we can figure out how this works by trying to find a pattern. Okay, so there are 3 more multiplication problems on there. Try all 3 of them, pause, and then come back to check your work. Okay, so taking a look, the answers we should have gotten, and I'm actually going to get rid of this stuff because really we just want to see problem and answer so we can see if we can find a pattern, okay? Answer to this one should have been x squared plus 10x plus 21. This one should have been x squared minus 13x plus 36. And the last one should be x squared minus 7x plus 6. Okay? So, what we're going to try to do is discover a pattern between the numbers in our answers and the numbers in our original problem. Okay? Pause and take a second to think, do you see a pattern between the starting problem numbers and the numbers in our answer? Okay, hopefully you've taken some time to think about that. The pattern that I see is, for example, in this one, we started with the numbers 2 and 4, and we ended with the numbers 6 and 8. 2 times 4 equals 8. 2 plus 4 equals 6. If we kind of look at that in all of these, that's the thing that seems to work out, right? 7 times 3 is 21. 7 plus 3 is 10. Same thing even down with the ones that have subtraction signs. 9 times 4 is 36. 9 plus 4 is 13. The only difference with the ones that have subtraction is that there's a subtraction sign in the middle. Okay? That seems to really be the only major difference we have. So the pattern that I'm assuming that I'd like you to write down here is that if we were kind of working our way from something that looked like this, with either a plus or a minus sign in the middle and a plus at the end, if you want to figure out what it factors to, you should be looking for 2 numbers that multiply to the last number. So in this case, I've labeled that with a C. And you should be looking for 2 numbers that add to B. Okay, and then your signs in the middle are just going to be the same as these signs. Okay, so if you have a plus in the middle, they'll both be plus. If you have a minus in the middle, they'll both be minus. Okay, let's go to the back and look at an example of each. All right, so basically what you're doing is, for this one, if I want to factor it, I know that my final answer is going to start with x and x, okay, because that's what all of my original problems look like when I was multiplying, right? They all began with x times x. That gets me the x squared. I also know, because I have a plus sign in the middle, that they're both going to be plus. Now I just need to find the two numbers. So I'm going to look for numbers that multiply to 26 and add to 15. Okay? Thinking of numbers that multiply to 26, that would be 26 and 1, or 13 and 2. 13 and 2 also add to 15, so I'm going to use 13 and 2. Problem B is done very much exactly the same way. Try problem B, pause, and then come back. Okay, I'm assuming you've tried problem B. Again, we start with two parentheses that both begin with x. That gets us our x squared. Then we stick a plus in there because we have all plus signs, and that's a plus sign right there. We're looking for numbers that multiply to 25 and add to 10. Those would be 5 and 5. 5 times 5 is 25. 5 plus 5 is 10, so we'll put a 5 in both parentheses. The only thing that changes even a little bit when you get to ones with subtraction signs is we're going to have an x and an x and a minus, okay? We are still going to be looking for numbers that multiply to 6 and add to 5, okay? Those numbers would be 3 and 2. And if you think about it, guys, this is why this really works. If you multiply the x through and the negative 3 through, what you're going to find is your two terms in the middle are negative 3x and negative 2x, so that's what gets you the negative 5x. But then when you multiply a negative times a negative, you still get a positive at the end, okay? Everybody try problem D, pause, and then come back. I'm assuming you've done that. You should have been looking for numbers that multiply to 14 and add it to 9. Those would be 7 and 2. And they both get minus signs, so we get a negative 9 in the middle, but a positive 14 at the end.